Now, here's where you have to step back for a second and think about the matrices. We don't need to use them, thank goodness. We don't need to use the matrices. But let's think about the matrices for our model. The model for our matrix involves everything in the matrix. Now, our lambda, the capital lambda, that was a 1 by 5 matrix. All the values were there, and we estimated, okay, we didn't technically estimate all of them. We estimated 4 of them, and 1 of them was fixed, though we had to fix 1 anyway. Now, but then one of the other matrices that we used was the theta matrix, which was the variance for all of our error terms on the diagonal. But there's zeros everywhere else. There were not just some, there were a whole bunch. In fact, I think there were 10 zeros. This is the test that will essentially say, look, if you change any one of those zeros, this is how much your modification index, sorry, this is how much your discrepancy function might improve. And the nice part is essentially it's just one matrix calculation, and it instantly tells you how the entire model changes if you change one of those variables, but it does it for you all at once. So if you think about having a really large beta, really large gamma, lots of lamp factor loadings, lots of variances and covariances, it asks, this one calculation runs and says, here's how they would change.
When you say one variable, what is the modification to that variable?
Yep. So right now.
No, I'm asking.
So this one is 6. So let's focus on the first one here. Yeah. EQ1 and EQ2 is the error variance between item 1 and item 2. It's saying if you were to change that variable, right now it's calculated as 0. Right now it's calculated as 0. I think EPC is the estimated parameter change.
Yeah, it's okay.
Expected parameter change. Okay, there we go. So if you were to free this, it thinks that the value would be about -0.05 as a covariance. Okay. Or standardized, i.e. a correlation, about -0.115. Not a very large correlation.
The covariance will change from 0 to -0.05 if you free the covariance.
Yep,
What do you mean by free?
Right now we fixed it to being 0. We're saying the error between item 1 and item 2, those two errors are uncorrelated. This is saying that if you go in and actually allow them to be correlated, then it estimates that the value would be about -115, and this will be just estimated, it's not perfect. And here's the best part. Your modification index should improve by about 18. Now, the modification index is actually the measure. That's how much our discrepancy function would change. So let me go back up so we can see what if we go back up, technically that's been scaled. If I scroll back up for a second, so my chi-squared was on 5 degrees of freedom. Let me write it over here. The chi-squared on 5 degrees of freedom was 182.74. And that was on 5 degrees of freedom. Now let's look at this. If I scroll back down here, my chi-squared would decrease, would get better by 18 if I freely estimated that. 30 if I freely estimated the error between Q1 and Q3. 53 if I estimated the error between Q1 and Q10. So, in the MI column, what do you want to look for?
The largest MI.
You look for the largest MI, which in this case happens to be item 2.
Item 2 with?
Item
with Q3 or
2 with
just?
3.
Okay.
Yeah, Q with Q. Sorry. Yeah, Q2 with Q3. Yep, those two together. Okay, so what we're going to do now is we're going to use this information and go back and change our model. We're going to use this information and go back and change the model. I just realized I should have kept track of a few other things here, but I'll do it. I'll do it after I run the model. All right, so what we're going to do is we're going to add that error correlation.
I have a question.
Yep, go ahead.
Well, more of just a concern. So something that I was thinking last time that I learned this was just like, so is there a way to keep track of, because when you start adding in all these different things, then you're changing the degrees of freedom and
Yep.
whether it's just identified or under identified
Yep.
or over identified. Like, so I just don't know how you keep track of that.
Part of it would be your degrees of freedom.
Okay.
Keeping, as you follow those, you'll know how many more things you can change or not change.
Okay.
Yep. Excellent. That's a very, very good question. All right, so what we're going to do is let's add, let me make sure I've,
Yeah.
okay, so the note, the way to add this is, oh, sorry, I just checked to see if it was a comma and my brain forgot yet. There's a comma. All right, so I'm going to say comma, COV, E dot Q2 star E dot Q3. That's the way to say the do the covariance between those. All right, so let me zoom in on that really quickly so it's a little clearer on the screen. All right, so that's the command to enter, and it will run. I'm going to zoom back out here. And now, look what I get. My chi-square now is on 4 degrees of freedom. My chi-square is on 4 degrees of freedom. It is 48.21. Now again, unfortunately, that's still not statistically significant. That's still kind of a distance off. Okay? I'm not really next to my 0.05 and above range, but that's okay. That's okay. Now, what I'm going to do is, let's go back and keep track. So let me bring up the goodness of fit value. So I'm going to say estat GOF, comma, stats all. You know what I realized yesterday? Or I forget what day it was. Monday? Stats is a palindrome.
Yeah.
You'd think after being a statistician for like this many years, I would have picked up on that. All right, let's look at our values. So we know, let me zoom out a little bit here. So we know that the, go up. Okay. So we know that the fit statistics, 48.21, is not significant. But let's look at our other values. So let's do the goodness of fit measures first. So we've got CFI equals 0.995. TLI, or it's also called the NNI, 0.987. Now remember, we want these to be above 0.95, so we're in excellent range there. Our two measures of badness of fit are SRMR, which is 0.009. We want that to be very close to 0, particularly less than 0.05. But now look at our RMSEA. Our RMSEA is 0.073. Now remember, 0.05 is what we want. The probability that this is 0.05 and it's only we're only seeing as 7.3 because of random noise is 0.016. So it doesn't clear the 0.05 threshold, but it's a lot closer. So is this less than 0.08? Well, we're probably a lot more confident that it's less than 0.08. Which is good, not excellent. So we went from this one, chi-square being bad still, to having an excellent, actually I'll put a star, excellent CFI, excellent TLI, excellent SRMR, and okay. I won't give it a star. I'll say it's, actually I won't give it okay, I'll give it a check mark. There we go. For the RMSEA. Now I'm just going to scroll back up so I can get the values and we can compare them to what we had earlier. Earlier we had 0.131 for the RMSEA. We had 0.980 for CFI, 0.959 for TLI, and 0.018. So again, these were still good,
These were all good, but this one was not good at all. That one didn't even make the okay range. So that's 0.13 is bad. Now, remember, the chi-square is what we use to make the statement about sigma equals sigma theta. Population equals the model. This unfortunately says reject that, but we're extra sensitive about that because we know it depends on the sample size. All right, I'm going to do something now that's a little tricky. I'm not trying to be tricky, but my thought is, depends on the sample size. Well, technically, I'm not using 2,062 values. I'm technically only using 15 values, the 15 distinct values in my matrix. So the fact that there's 2,062 is something that I tell the program, but it really only needs the covariance matrix. So what if I changed my n? What if I said, oh, you know what? No, it's not 2,062. Actually, it's only 200. Okay. Now I'm being a little sly, and just so you know, I'm not doing anything scrupulous. Other programs actually report the value that I'm going to walk us through the calculation for right now. Right? I'm going to take this 48.21 and think about it for a bit. Let me actually get the slightly better value. I think it was so the value was 48.212. All right, so let me bring up Excel. So I'm going to zoom out again for a second here. Let me zoom out.